Hey kiddos, today we're doing the nth term test, so get your salmon sheet out and ready to fill in after this video. We'll fill that in together, but let me teach you nth term test first. So this test comes from this theorem that is written for you. The theorem says if this is a series, so if this series converges, then the limit as n goes to infinity of its terms. These are the individual terms of the series. Remember that a series is a sum. So it's saying if you add up all the terms and that converges, then the terms themselves have to be approaching zero. And that should make some sense to you. The only way a sum is going to approach a value is if the terms are getting so small that they don't matter anymore. They're getting so tiny that they're not affecting the sum anymore. So that's what the theorem says, but it's a wildly unhelpful theorem for what we're trying to do. Remember, our goal is to figure out if the series converges or diverges. So starting with a theorem whose hypothesis is that it converges, and then this is true, is not helpful. We are going to go back to geometry, and we are going to write the contrapositive. So I don't know what you remember about truth tables. I remember them being fun. But there is the thing that says if you have a true statement, then its contrapositive is always true. So we're going to write the contrapositive of this statement and use that version instead. So the contrapositive, this is P then Q. A converse is when you just switch them. So Q then P, that's not what we're doing. That one's not necessarily true. An inverse is where you negate each. So not P, then not Q, also not what we're doing. Contrapositive does both of those things. So we're doing not Q, then not P. All right, so if this one's Q, let's write this now. Now it says if the limit as n goes to infinity of a sub n is not 0, then not P would say the sum, so the series, not P, so not converges, diverges. This is the version we are going to use. We are going to take a limit of the terms of our series and not get 0. And we can say therefore diverges and be done. If you do get 0, if you work so hard at your limit and you get 0, you know nothing. It is inconclusive. You must go do another test, which for you right now means geometric because that's all you know. So let me show you a couple examples. So these are only as tough as the limits are, obviously. And I need to remind you of some shortcuts with limits. So that's what I'm going to try to do now. So here is a sum. I'm going to use n again. Let's do like 2n minus 1 over n plus 6. So what we're doing is we are taking the limit of these terms. So 2n minus 1 over n plus 6 as n goes to infinity. And we're taking a limit, just like the good old days of limit taking. Do you remember your shortcuts? If n is going to infinity, you can use 3 shortcuts where you look at the degree of top and degree of bottom. Well, these have the same degree, so I'm going to look at their leading coefficients, and this would be 2 over 1, which is 2. All you have to do is say, hey, that's not 0, therefore diverges. And it's that fast. You don't get 0, you say therefore diverges by nth term test. Another. So if I ask you to do like the cosine of n pi, and we go try to take that limit, the limit of cosine. All right, so I know what cosine looks like, and I know it's stuck between -1 and 1 all the time. So it oscillates back and forth between negative and 1, every value in between, but it doesn't ever approach 0. It doesn't get to 0 and stay there. I don't know what it is, but it's not 0, and that's all I have to write. Therefore, diverges by nth term test. Okay, so then what if you have something a little scarier looking, perhaps, like something like this? All right, well, maybe that's actually not that scary. But if I go and take a limit and goes to infinity, 1 over 3 to the n minus 1 over 4 to the n. Let's see, this is 1 over big, 3 to the infinity. So 1 over big, that's going to 0. Minus 1 over big, that's going to 0. I get 0. It means I know nothing. That means that test was inconclusive and I have to do a different one. So lucky for you right now, the only other thing you know is that it has to be geometric because those are the only 2 tests at your disposal right now. This is where series get hard, friends, is you're going to have all these options and you're not going to know where to start. So my advice to you is to always start with this limit test. And you can take this in your head. You don't even have to write it out because if it equals 0, you just wasted time anyway. But I know about 1 over 3 to the n. I know that's 1 over 3 plus 1 over 3 squared plus 1 over 3 cubed. That's geometric with r equals 1/3. And then I know about 1 over 4 to the n. That's 1 over 4 plus 1 over 4 squared plus 1 over 4 cubed. That's geometric with r equals 1/4. Well, this one has an r value less than 1, therefore converges. This one has an r value less than 1, therefore converges. And a converge minus a converge still converges. And I could write that out much more formally, but I won't. Let's go to your salmon sheet and fill it in, your series list. So we are going to call this one the nth term test. And the note that I want to put here is that you're going to use this first. When I cycle through my options, I always do this one first. All right, so here's what we do. We are going to take a limit of our terms as n goes to infinity and get 0 for divergence. And we are going to put nothing in the converge column because there is no such test as an nth term test for convergence. If you don't, we're going to take a limit and not get 0. If you do get 0, then you know nothing and you got to do a different test. All right, let me know if you need anything, kids.